Hello everyone, welcome back to our channel. Today we are going to study a very interesting algorithm. It's called the Z algorithm. It's part of the pattern matching algorithms, okay? And it's one of the most powerful one of them. So listen to this very carefully. You'll see a lot of questions that you can solve using this algorithm. Mainly any hard level pattern matching question that you see, you're going to be able to solve it through this one. So let's get started. So here we will create a Z array. Okay, there's a very important part of this algorithm called as the Z array. What does each index signify inside this array, the Z array that we're going to create? So basically any index k, z of k, will signify longest substring starting at k which is also a prefix of the string. What does it mean? Let me show you with an example how exactly this Z array looks like. So let's take a string a b x a y a b. So this is a string. Okay, let's name it T. Under this, I'll create the Z array for you. So at index, let me write the indices 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. The string is 10 characters long. The zeroth index, whatever there is, it doesn't matter. So we can write anything. Let's write a 0 over here. Now for index 1, what are we going to do? We are going to find the longest substring starting at index 1 that is also a prefix of this whole string. So we compare this with this. They are same, A and A are same. Okay. So we move both the pointers forward. A and B are not same. So starting at index 1, there is a string of length 1 that is also a prefix of this whole string. Okay. Moving forward. Now we come at B. Okay. We compare B with A. They are not same. So there is a string of length 0 that is also a prefix. Then we move forward. We come to x. X again is not equal to A. So again, we put a 0 over here. Next, what we do is we come to index 4. Now A will be matched with this. A and A are same. Very good. Move both the pointers forward. A and A are again same. Move both the pointers forward. B and Y are not same. So at index 4, there is a string of length 2 that is also a prefix of this whole string. And I'll just highlight these two things for you. This is the substring I'm talking about, and this is the prefix. Both are of length 2. Okay. Now moving forward, coming to index 5. A is matched with A. Both the pointers are moved forward. Y and A do not match. So the length is 1 for this. Moving forward. I hope it's clear so far. Whatever doubts you get, guys, once again, I'll just remind you. You can put them in the comment section below, and I'll be more than happy to answer each one of you. Y is matched with A, does not match. Moving forward. A is matched with A, matches. Move both the pointers forward. A is matched with A, again matching. Move both the pointers forward. B is matched with B. Very good. So a length of 3 substring is there, which matches with the prefix. Okay. Now moving forward, coming to index number 8. A is matched with A, well and good. Moving forward. B and A do not match. So here the length is 1. Now for the next one, B is matched with A. They don't match, so here the value would be 0. So I hope this is clear to you what Z-array exactly looks like and what it represents. All right. Now moving on to a practical example. How will we find a particular string in another string? So let's have a look at that. So now we are going to take two strings. There's going to be a text. Let's take the text as X, A, B, C, A, B, Z, A, B, C. And the pattern, let's take that as A, B, C. Okay. Now what we will do is we will create a new string. Okay. A new string. How will we create this string? Look at this very carefully. This will be equal to pattern plus a character that is neither in the text nor in the pattern. Okay. We have to take a unique character that is neither in the text nor in the pattern plus text. So in this case, what would it look like? A, B, C, dollar, X, A, B, C, A, B, Z, A, B, C. Under it, we are going to create the Z array for this whole string. Now look at this very carefully. We are going to just repeat what we did over here. Okay, it's nothing new, nothing fancy. We are just going to repeat that. See, at index 0, let me write the indices so it's more clear for all of us. Okay. And make sure to watch the whole video, guys. Okay. Don't think that you know enough now and you can skip. Just watch the whole thing. It will be crystal clear to you. And you'll be able to solve a lot of questions with this particular algorithm. Now, at 0, you can write anything. We'll just start with 0. Now coming to index 1, B is matched with A. Do not match. This is 0. C is matched with A. Do not match. This is again 0. Dollar is matched with A. Do not match. This is a 0. Then X is matched with A. Do not match. Again a 0. A is matched with A. All right, move both the pointers forward. B is matched with B. Perfect. Move both the pointers forward. C is matched with C. Again, they match. Move both the pointers forward. Dollar does not match A. So here, there is a string of length 3 that is present over here and as the prefix, right? ABC, ABC. Now, moving forward, B is matched with A, nothing matches. C is matched with A, again, nothing matches. This is also 0. Now A is matched with A, they match. Move the pointers forward. B is matched with B, good. Now C is matched with Z, do not match. So here there is a string of length 2 that is also a prefix of this whole string. Moving forward, this B is matched with A. They do not match. So here the value will be 0. Then this Z is matched with A. Again, the value will be 0. They do not match. A and A, they match. Moving forward, B and B match. Moving forward, C and C again match. So here is a other substring. Here's another substring of length 3 that is also a prefix. Moving forward, B does not match with A. So here we'll put a 0. And C does not match with A. Here we'll put an other 0. Now, how do we find where the pattern exists? See, the length of the pattern is 3. Right? Everybody agrees with me. Length of the pattern is 3. And that is also the prefix of this whole new string. Right? So wherever the Z string will give you a 3, that means that here is a substring of length 3 that is also a prefix. And we know that pattern is the prefix of length 3. So we know that the pattern exists over here, and here's another 3, so the pattern exists over here as well. How do we find out the index of the pattern in the real string? I'll just put in the indices 1, 2, 3, 4, 5, 6, 7, 8, and 9. See, what have we added to the text? The complete pattern plus a character. So pattern's length is 3, character is of 1 length. So 3 plus 1, 4. If we subtract 4 from 5, 5 minus 4 is equal to 1. On index 1, you will find the pattern. If we subtract 4 from 11, 11 minus 4 is equal to 7. On index 7, you will again find the pattern. So this is how we can find or search for a pattern in a given string. Now let me show you how we actually do this in linear time complexity. First, I'll give you a theoretical walkthrough, and then we'll have a look at the pseudocode as well. All right, once again, let me remind you, whatever doubts you get, you put them in the comment section below. All right. Now, let's take this long string A, B, X, A, B, X, C, A, B, X, A, B, X, A, Y. Okay. Now let's calculate the Z array for this. Look at it very carefully what I'm going to do next. Okay, so on index 0, let me write the indices 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. Now on index 0, you can write anything, it doesn't matter. So we'll just start with a 0. On index 1, match this. A will match with A. Very good. Move forward. It doesn't match. So here we'll put a 1. Now B is matched with A. Do not match. 0. X is matched with A. It does not match. 0. Next, A is matched with A. It matches. Good. Move forward. A is matched with A. It again matches. Move forward. B is matched with B. Good. Move forward. X matches X. A does not match C. So there is a string of length 4 over here that matches the prefix. Let me just highlight that once so it is clear to all of you. Okay, the prefix and this substring match. Now, this is my Z box. Okay, this is called the Z box. This is the left and this is the rightmost part of it. What we are going to do is, instead of again comparing for this A, 1 second, let me highlight it. For index 5, we won't compare the whole thing from start. We already know this string is same as this string that I've highlighted in blue. So whatever values will come over here, there will be a copy of these values. Okay. So next, what value corresponds to this index 5? That is index 1. And the value is 1. Next, for index 6, value is 0. For index 7, value is 0. So like this, we can simply pick and copy these values instead of recalculating the whole thing. There is one corner case to it. I'll show you in this string. It will occur. Okay. Now next, for index 8, C is matched with A. It does not match. So value is 0. Move forward. A is matched with A, matches. Let me move the pointer forward. A matches A, right? Then we move both the pointers forward once again. B matches B. Good. X matches X. A matches A. A matches A. B matches B, X matches X, A does not match C. So there is this string that is also a prefix. AAB, XAA, BX. Now, what is the length of this string? 1, 2, 3, 4, 5, 6, 7, 8. So the value here is 8. And as I told you, now we don't have to recompute for everyone, right? We can simply copy paste the values. For the Z box, this is the left end, this is the right end. For this A corresponds, right? What is the value here? 1. Just copy 1 over here. Move both the pointers forward. Value here is 0. Put a 0 over here. Move both the pointers forward. Value here is 0. Put a 0 here. And move both the pointers forward. For this, the value is 4. Right? Now, the problem with 4 is this is the corner case. Look at this very carefully, okay? You'll be able to understand this in one go. The problem is with a value of 4, this reaches the end of our Z box, the Z box. What is the problem? We haven't seen the characters in front of it. Maybe they again match with the prefix. So this is the problem here. What we will do is, now we will reduce our Z box, okay? We will reduce it to this much. And this corresponds to this prefix. Now the value here, it's supposed to be 4. What we will do is, we will compare this with this because we haven't checked anything outside the Z box. And they also match. So now the value here would be 5. Moving forward, now they don't match. So the value here is 5. And the new Z box would look like this. L would be here, R would be here. Now we can again, in a similar fashion, copy the values. This is the corresponding prefix of length 5. With this A, we have this A, length is 1. With this B, we have this B, 0. With this X, we have this X, again a 0. With this A, we have this A. Length is 4. Length 4, once again, corner case, length 4 is going out of the Z box, and we haven't checked the characters out of the Z box. So we again don't know. So what do? We again create this new Z box. L is here and R is also here. And this is the A to which it basically corresponds to. We will check A with Y, they do not match. So the value here stays 1. And for Y, it doesn't match with A, so the value is 0. So this is how we basically are going to create the Z array. Okay, the Z box is a concept that will help us save the time complexity by not rechecking the entire string from the start. Now we are going to move to the pseudocode, and whatever doubts you have so far, put them in the comment section below. Okay. All right, so now we'll be moving on to the pseudocode. Listen to this part very carefully, and this algorithm will become crystal clear to all of you. First of all, what we are going to do for the Z algorithm is, let's take the length of the input array as n. Now this string s is going to be the pattern plus the random character plus the string we have to look into. Okay. After this, we create the Z array or the Z array. Then we initialize Z0 with a 0 because the 0th index does not matter. Then we have to initialize 2 pointers for the Z window, right? L equal to 0, R equal to 0 initially. Now we will iterate. From 1 to n minus 1 using the iterator I. Inside this, we have to check if I is greater than R, which means that we are outside the Z window. What do we have to do in this case? First of all, we'll make L equal to I, then we'll make R equal to I. So we have shifted the Z window to the current index. Inside this, we'll run another loop while R is less than N and S of R minus L is equal to S of R. Let me explain to you what this exactly means. Okay. So R should not exceed the given string, it should not go out of bounds. That's R less than N. Then what is this condition? See, there's a R, there's a L. Let's take a random text. Let's say this is the string. This is the L, this is the R. Okay, let me write the indices. Now we are matching these characters with the characters at the beginning, right? Our window is already of size 3. 5 minus 3 is 2. So we are matching this character with this character. Why? Because you already know that these two characters are matching. If they match, we will move R forward. Okay. So basically expanding the window to this. Now this is our R. What do we have to match 6 with? Now we have to match 6 with 3. See, once again, we'll use the same formula. We'll match S of R minus L with S of R. So we are going to match this with 6 minus 3, that is 3. Right? Because you already know that this much of the string is already matching. So this is why we are using this formula. If they are basically equal, what we are going to do is we are going to move R forward. We're going to do a R plus plus. Once we come out of this and the characters are no more equal, what we'll do is we'll make Z of I equal to R minus L, because R minus L will give you the window size. The size where the substring is, that is equal to the prefix, right? So we'll make Z of I equal to R minus L. And on top of that, we'll make R equal to R minus 1 once again, because R has gone one step further where it did not match. So we'll move it one step back again. If this is not the case, if we are not outside the Z array, right? This was when we are outside the Z array. Let me write that down. If I is greater than R, it means we are outside Z array. If this is not the case, now we will make the else part. Okay. This basically means we are still inside the Z array. All right. Now, as I told you, to improve the time complexity, we are going to copy the corresponding numbers from the Z array, right? Not going to do the whole thing again. Inside the else, the first thing that we'll do is we'll calculate the variable I. This is basically the index corresponding to prefix. I'll tell you what this means. Okay. So let's say this is our string and this is our Z window. Let me write the indices 0, 1, 2, 3, 4, 5, 6. Okay. Now, where are the matching characters? Here, right? Let's say A, B, C, A, B, C, whatever. Now, our I is, let's suppose, over here. The corresponding character is over here, right? How do we calculate it? This is L, this is R, and this is I. So L is equal to 3, I is equal to 4. 4 minus 3 is equal to 1. And you can see that we have calculated the correct corresponding character here. So this is how this formula I minus L will give you the correct corresponding character. Now to move forward from here, we have a if condition where we are going to check if Z of K, okay, is less than R minus I plus 1. So here we are checking whether we are still inside the bound of the Z array or not. Okay, this is that check. If it is inside, we simply copy. We don't have to do anything. Z of I is equal to Z of K, as we were doing in the dry run. If this is not the case, right, then we have to check further characters. Else, if this is not the case, what can we do? We have to make L equal to I, right? We're changing the Z array. And again, we'll run the same loop. While R is less than N and S of R minus L is equal to S of R. What do? We do R plus plus. And after this, we make Z of I equal to R minus L, and we do a R minus minus outside it. At the end, when we are done with all of this, we can come out of this loop that started on point number 5. We can come to point number 6, and we can return our Z array. So you return Z over here. So this is the Z algo, guys. This is how we create the Z array. I hope everything is crystal clear to all of you. For all the doubts that you have, you always have the comment section below. Please put in all your comments there, whatever doubts there are, and I'll be more than happy to clarify all the doubts that you have. See you in the next video, guys.